Debugging. Errors in computer solutions are called bugs. They create two problems. One is that the error needs to be corrected. This is normally fairly straightforward because most errors are caused by silly mistakes. The second problem, however, is much more complicated. The errors have to be found before they can be corrected. Finding where the error is and identifying it can be very difficult, and there are a number of techniques available for solving such problems. 1. Translator diagnostics. In section 1.3.c we were introduced to the idea of a translator program. Each of the commands that are in the original program is looked at separately by the translator. Each command will have a special word which says what sort of command it is. The translator looks at the special word in the command and then goes to its dictionary to look it up. The dictionary tells the translator program what the rules are for that particular special word. If the word has been typed in wrongly, the translator will not be able to find it in the dictionary and will know that something is wrong. If the word is there, but the rules governing how it should be used have not been followed properly, the translator will know that there is something wrong. Either way, the translator program knows that a mistake has been made, it knows where the mistake is, and, often, it also knows what mistake has been made. A message detailing all this can be sent to the programmer to give hints as to what to do. These messages are called translator diagnostics. 2. Sometimes the program looks alright to the translator, but it still doesn't work properly. Debugging tools are part of the software which help the user to identify where the errors are. The techniques available include A. Cross-referencing. This software checks the program that has been written and finds places where particular variables have been used. This lets the programmer check to make sure that the same variable has not been used twice for different things. B. Traces. A trace is where the program is run and the values of all the relevant variables are printed out, as are the individual instructions, as each instruction is executed. In this way, the values can be checked to see where they suddenly change or take on an unexpected value. C. Variable dumps. At specified parts of the program, the values of all the variables are displayed to enable the user to compare them with the expected results. 3. Desk checking is sometimes known as a dry run. The user works through the program instructions manually, keeping track of the values of the variables. Most computer programs require a very large number of instructions to be carried out, so it is usual to only dry run small segments of code that the programmer suspects of harboring an error. In section 1.3.b we discussed the splitting up of a problem into smaller and smaller parts, until each part was a manageable size. When the parts were combined, they would produce a solution to the original problem. Because we are starting with a big problem and splitting it into smaller problems, this was called top-down design. When the program is written, each small program is written separately, allowing the small programs to be tested thoroughly before being combined. This is called bottom-up programming. The technique is particularly useful for testing the finished program because it is far easier to test a lot of small programs than it is to test one large one. One problem can arise, because the small programs have to be joined together. These joints have to be tested too to make sure that no silly mistakes have been made, like using the same variable name for two different things in two parts of the program, tested by cross-referencing. 5D test strategies are important to establish before the start of testing to ensure that all the elements of a solution are tested, and that unnecessary duplication of tests is avoided.